Okay, so this little lecture is going to cover the second lobe of the pituitary gland, so the anterior pituitary gland. It's going to release the most amount of hormones that we're going to discuss coming from one gland. So the anterior pituitary gland releases the growth hormone, the thyroid stimulating hormone, adrenocorticotropic hormone, follicle stimulating hormone, and luteinizing hormone. The FSH and the LH are collectively referred to as gonadotropins, and then we also have prolactin release. Also, when we talk about these different hormones, a lot of them are amino acid derivatives. So if you remember, any of the hormones that are derivatives of amino acids means that they cannot cross the plasma membrane of whatever the target tissue or cell is. So they have to use a second messenger system. So all of these hormones, with the exception of the growth hormone, use cyclic AMP as their second messenger system. Another thing when we're talking about the hormones released from the anterior pituitary gland is that four of them are what we call tropic hormones or tropins, meaning that they go on to regulate the secretion of other hormones. So when they are secreted, they go act at another endocrine gland to cause the secretion of another hormone. So that's basically what a tropin is. And one of which would be our thyroid stimulating hormone. So, for example, TSH is going to go to the thyroid gland to stimulate the release of another hormone, one of two. Um, and so on with where our ACTH as well as our gonadotropins. And tropins actually in their name. Okay, so now we can go up and talk a little bit more about the anterior pituitary gland in general. It used to be called the master endocrine gland. It's not really referred to that anymore. The reason why it was called the master endocrine gland is because, like I just showed you, it releases 6 different hormones. But now they've realized that even though it's releasing 6 different hormones, the release of these hormones is actually under control of the hypothalamus, which we talked about earlier. So the hypothalamus controls both the release from the posterior and the anterior pituitary gland. However, it does synthesize and release its own hormones, so that's different than the posterior pituitary gland because remember that one just functions basically as a storage space and it doesn't actually synthesize its own hormones. The reason why the anterior pituitary gland does synthesize and release its own hormones is because it doesn't have any neural connection like the posterior pituitary gland. Okay, so now we can go in and talk a little bit about the functions. So when we're talking about the growth hormone, it has 2 different effects. One that we say is direct and one that we call indirect. So the direct effect is also what we call the metabolic effect. And the metabolic effect means that the growth hormone can directly increase blood glucose and it can increase fat breakdown or lipolysis. So both of these help increase metabolism. Okay, the more glucose we have and the more fat we have, the more we can metabolize, our cell can undergo metabolism. If we're increasing our blood glucose, that's the opposite effect of insulin, which tries to lower blood glucose. So we can also say the growth hormone has an anti-insulin effect. Okay, in regards to indirect effects from the growth hormone, we consider these things that promote growth, so growth promoting actions. So, in one way it does this is that it can act at the liver to cause the liver to produce something called the insulin-like growth factor or IGF. And the insulin-like growth factor has some targets as well, and those predominantly are going to be skeletal and cartilage tissue. So it's going to increase skeletal and cartilage growth. And it can act on other tissues other than the skeletal system and cartilage and increase protein synthesis and cell proliferation or mitosis. So these are the growth promoting effects. Again, they're the indirect effects. I gave you the example using the liver, but it can also act at several other tissues in the body as well. So let's talk about what stimulates the release of the growth hormone. And this one's kind of in its name. So something called the growth hormone releasing hormone is going to stimulate the release of the growth hormone. And what's going to inhibit it? Something called the growth hormone inhibiting hormone is going to inhibit its release. Other things that can increase or stimulate the release of the growth hormone would be low levels of growth hormones in general, or if we have low blood glucose. Because remember, one of the direct effects of the growth hormone over here is to increase blood glucose. Other things that could inhibit it, other than the growth hormone inhibiting hormone, are high levels of the growth hormone or high levels of the insulin-like growth factor. So you'll notice not just with the growth hormone, but the bulk of these hormones released from the anterior pituitary gland, that they function off of a negative feedback cycle. So if you remember what that is, once we get high enough concentrations of the hormone produced, those high concentrations cause the hormone to go back to the beginning to shut down the synthesis of the hormone to begin with. So we can have the growth hormone, high levels of it, go back to inhibit the release of its own self, basically. So high levels of growth hormone inhibit the release of more growth hormone. Okay, so now let's talk about some conditions in which we may have hyposecretion or hypersecretion of the growth hormone. If we have hyposecretion of the growth hormone, we get something called pituitary dwarfism. This is a specific form of dwarfism because we do have genetically based dwarfism as well. And typically, the child or adolescent in adulthood would reach a max height of around 4 feet. We can have the opposite effect if we have hypersecretion of the growth hormone, in which we can get gigantism in a child or something called acromegaly in an adult, where we can reach about 8 feet in height will be actually pretty common. Okay, so now let's move on to the second hormone released from the anterior pituitary gland, and this is going to be our thyroid stimulating hormone. So its function is probably obvious. So it's going to aid in the normal development of the thyroid. And it's going to help with the secretory activity of the thyroid. What's going to cause it to be released from the anterior pituitary gland? We have another hormone, TRH. But before I tell you what TRH stands for, I want to point out that the thyroid stimulating hormone is also called a thyrotropin, because that will make sense why TRH stands for thyrotropin releasing hormone, not thyroid releasing hormone. So thyrotropin releasing hormone, or TRH, if we have any of that, that's going to stimulate the release of the thyroid stimulating hormone, and it's released from the hypothalamus. What's going to inhibit the release of the thyroid stimulating hormone? If we have high levels of thyroid hormones, And if we have high levels of IGF or the insulin-like growth factor, all of that would inhibit the release of the thyroid stimulating hormone. So now let's talk about hyper and hyposecretion of this hormone. Um, if we have hypersecretion of the thyroid stimulating hormone, we get symptoms similar to something called Graves' disease. If we have hyposecretion of the thyroid stimulating hormone, we could possibly get myxedema. Spell that wrong. Edema. I'm not going to talk about what these are right here. I'll mention them when we talk about uh, their outcomes from the thyroid hormone itself. So those are the two results if we get the thyroid hyper or hyposecretion of the thyroid stimulating hormone. Let's move on to the next one. So the third one released by the anterior pituitary gland is the adrenocorticotropic hormone. What is its function? It's going to stimulate the adrenal cortex. So that's in its name, adrenocortical. So adrenal cortex to release corticosteroids. So, for example, glucocorticoids is a corticosteroid. And what do these functions do? They help resist various stressors if our body's under a lot of stress. What causes its release or stimulates its release from the anterior pituitary gland would be CRH, which is the corticotropin releasing hormone that would stimulate it. What would inhibit it? If we have high levels, again, we're working off a negative feedback, so the product of it or the outcome of it would be to produce glucocorticoids. If we increase our levels too high, they can go back and inhibit the adrenocorticotropic hormone and CRH, or the corticotropin releasing hormone. So the only one that you have to worry about here is going to be what happens if we have an hypersecretion of ACTH, and we could get something called Cushing's disease. And we'll talk about this later. Okay, the fourth and fifth hormones released by the anterior pituitary gland, that would be your follicle stimulating hormone, or FSH, and your luteinizing hormone, LH. We lump these together and collectively refer to them as gonadotropins. And these are going to work at your ovaries and testes to help regulate their function. So let's talk about FSH first. So the follicle stimulating hormone, it doesn't matter what sex you're in, if you're a male or a female, they basically function to stimulate production of your gametes. And your gametes are basically your eggs and your sperm. So that's what it does in both sexes. Additionally, if we're talking about being a female, we can have FSH work in conjunction with LH, or the luteinizing hormone. And when it works in conjunction, it causes the eggs and the follicles to mature. And LH alone in females can trigger ovulation, as well as ovarian hormone synthesis. and release. In males, basically the only gonadotropin that functions in males is going to be LH, and LH is going to function in the testes to produce testosterone. Okay, and I forgot to mention, I just realized the function of the luteinizing hormone, which is basically to promote production of gonadal hormones. Okay, so now let's talk about what causes them or stimulates them to be released, as well as what would inhibit them. So, we're going to talk about this collectively as gonadotropins. So, we have something called gonadotropin releasing hormone, which is going to be released from the hypothalamus to stimulate the release of gonadotropins from the anterior pituitary gland. What's going to inhibit it? If we have high levels, again, we're still functioning off of negative feedback, high levels of gonadal hormones, such as if we have high levels of FSH and LH, this would cause gonadotropins to be inhibited from being released. Okay, so let me talk about hyposecretion. The only thing, like I said, if I don't mention it, you don't need to know it, but I do want to mention hyposecretion of gonadotropins. And basically, what happens if this happens is we fail to mature sexually. Okay, so now let's move on to our last hormone released by the anterior pituitary gland, and that's going to be prolactin. So it's a little bit different. Well, not really a little bit different. We're really focused on prolactin's effect in females. So in females, the effect is going to be to stimulate milk production. Do not get this confused with, so I'm going to put it in red, oxytocin, which we talked about being released from the posterior pituitary gland, in which it stimulates milk ejection. So those are two different things. So oxytocin, milk ejection, prolactin, milk production. In males, it's kind of debated, and because it's debated, I consider unknown, so function unknown. Okay, so what stimulates its release from the anterior pituitary gland? We have something called PIH, which is prolactin inhibiting hormone. So before I go further into this, I do want to point out that the previous 5 hormones that we talked about being released from the anterior pituitary, all of those hormones go in to stimulate the release of another hormone. So when we talked about the gonadotropin releasing hormone, that's going to stimulate the release. When we talked about CRH, that's going to stimulate the release of the hormone, and so on and so forth. This is unique in that we are working with an inhibitory hormone when we're talking about prolactin. So prolactin release is controlled by an inhibitory hormone, and that's called PIH, the prolactin inhibiting hormone. So we would want low levels of an inhibiting hormone, known as PIH, in order to release prolactin. And PIH is more commonly referred to as dopamine, which I'm sure you've heard of. So this would stimulate the release. In contrast, if we had high levels of the prolactin inhibiting hormone, we would expect that that would inhibit the release of prolactin. Okay. Again, let's talk about hypo and hypersecretion of prolactin. Hyposecretion would mean if you were pregnant or had just given birth, that if you don't have enough prolactin being secreted, then you are going to lower your production of milk or milk. If we have hypersecretion of prolactin, we get basically the opposite, which is called galacturia. And what this causes is basically milk production that's not going to be related to pregnancy at all. So maybe you're not even pregnant, but if you have a ton of prolactin being released, it could cause you to basically produce milk not from the proper response. Also, if we have increased prolactin release or hypersecretion, it can also cause infertility in females. Okay, so that's it for the anterior pituitary gland. Something I also want to point out is while you're kind of working through the details of this, make sure you pick up on the big picture. Like for example, where are the targets for these hormones? So if we're talking about the growth hormone, it pretty much works everywhere in the body. I talked about that. Its majority primary target is going to be the skeletal and cartilage tissue. However, it can work at other tissues to increase protein synthesis and cell proliferation. If we're talking about the thyroid hormone, stimulating hormone, that target of that hormone is going to be the thyroid. The adrenocorticotropic hormone, that target's going to be the adrenal cortex. And if we're talking about the gonadotropins, that target is going to be the ovaries and testes. And if we're talking about prolactin, the target of the hormone is going to be breast tissue. And that's it. Now we've finished the pituitary gland, which is probably the most complicated gland that we have.